Hey guys, in this video we're going to talk about combining like terms, the distributive property, and a special case of the distributive property known as FOIL. Alright, so first thing we're going to do is a little bit of a warm-up to just kind of get us going here. So a few videos ago we talked about terms and expressions and operators and coefficients, all of these vocabulary words. So remember that a term is just something stuck together with multiplication. Stuck together by multiplication. So, with that being said, let's go ahead and do this as a review. So here's an expression, a bunch of stuff added and subtracted together. So what are the terms going to be? Well, again, the terms are going to be anything stuck together with multiplication. So the first term we have is 2xy, 2 times x times y, that's a term. Second term we have is negative 3x squared. We have negative 3x squared, followed by 4b squared c cubed. So 4b squared c cubed. Again, anything that's separated by a plus sign is a term. Now right here, there is understood to be a plus sign in front of that minus, but a plus and a minus make a minus, so we don't need to write it. Okay. And the last one, last but not least, is negative 5. Plus negative 5 is a term. So negative 5 is our term. So we have 4 terms. All right, let's do the next one. I encourage you to pause the video and see if you can remember how to do this. All right, so we have 1/2 x squared followed by negative 4xy squared z, all stuck together with multiplication. Plus sign separates the terms. We get 8x. That's our next term. Minus sign again separates. So we have, but remember it's plus a minus technically. So this is going to be minus 3 is our next term. And then after that, our last term is going to be 6x squared. All right, what about this one? So everybody's multiplied because there's no plus or minus between any of the letters. So we just have one term. And that's this blah, 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 blah. It looks like you just like slammed your head on the keyboard or something. So it's just A times B times C times D times E times F times G times H. Now, if I had something like this, A plus B, C, D, E, F plus G, H, then I would have 3 terms because I had one, another one here, and another one here, right? Terms are separated by plus signs, and that's the review that we have here. Okay. So now we're going to learn something new called like terms, new concept. And so like terms are terms that have the same exact variables and the same exponents on the variables. Like everything has to be the same basically. The only thing that can be different are the coefficients or the numbers in front of the variables. So like terms can have different coefficients as long as they share the same variable and the same exponent. So let's look at some of these examples and determine whether the pair are like terms, whether the numbers are like terms. So here we have negative 2x to the 5th, and we have 4x to the 5th. Are these like terms? Well, they both have a variable x, so condition 1 is satisfied. Condition 2 says the same exponents need to be on the variables, and the exponent on the variables are 5. And number 3 says you can have different coefficients, and actually we do have them right here. We have a negative 2 on this term and a 4 on this term. The coefficients don't matter. The only thing that matters is the variable, and the exponent on the variables have to be the same. So, with that being said, yes, these are like terms. We have the same variable x, the same exponent 5. Okay? What about number 2? We have 3x squared and 2x. So, our first condition is satisfied because both of these terms have an x, right? We have the same variable. is the second condition satisfied? Do we have the same exponents on the variables? Well, here we have an exponent of 2 on the variable. Here we have an exponent of an understood 1 to be on the variable, right? If there's no number written, it's understood to be 1 on the variable. So because of this, because condition 2 isn't met, no, these are not like terms. We have to have condition 1 and condition 2 met. What about number 3? We have 7xy and xy. So condition 1 says I need to have the same exact variables. And in this term, I have xy as my variables. In this term, I have xy as my variables. So condition 1 is true. Now condition 2 says I need to have the same exact exponents on the variables. So on my first term right here, I have a 1 on the x, understood, and a 1 on the y, understood. In my second term, xy, I have a 1 on the x, understood, and a 1 on the y, understood. So this checks out, right? We have the same variables, x and y, and the same exact exponents on the variables. Okay? What about this one? We have 4x squared y squared, and then we have 3x squared y. So does condition 1 check out? Do we have the same variables? Well, in term 1, we have x and y as our variables. In term 2, we have x and y as our variables. So condition 1 checks. Condition 2 says I need to have the same exact exponents on the variables in the same spots too. So I have a 2 on this x and a 2 on this x. That checks out. But look at the y's. Here I have a 2 on this y, but I have a 1 on this y, right? And so this is not going to check out because I have to have the same exact exponents on the corresponding variables. So if this 1 was a 2, then the answer would be yes, but it's not. So the answer is no, these are not like terms. -6 and 10, are these like terms? Well, yeah. Now, there's no variable explicitly written, but you can think of this as x to 0, x to 0, if you want to think about it like that. Because anything to the 0 power is just 1, so it's like literally just -6 times 1, 10 times 1, if you want to think about it that way. If you think about it this way, we have the same variable and the same exponent on the variable. I mean, I guess, yeah, maybe, I don't know if you should think about it this way or not, but, because I guess technically you could have x to the 0, y to the 0, and that wouldn't make sense, but you know what, maybe I'm just going to backtrack and say, just think of constant numbers as being like terms. That's simpler. So yes, this could be an exception to our rule. We have basically we have the same power on the exponent of the variable that we choose. So -6 and 10 are like terms. So just remember that numbers just by themselves are like terms. Okay. All right, so this one we have 2ab and we have -6a squared b squared. Does condition 1 check out? Do we have the same variables? We have an a and a b right here, and over here we have an a and a b, so that checks out. However, condition 2 is not going to hold because in the left term we have a to the 1, b to the 1, but on the right term we have a squared and b squared, so the exponents aren't matching up. So no, these are not like terms. And here's a cute little picture to illustrate like terms. So these guys are saying we're alike because they have the same variable a and the same exponent on the variable 2. So these are like terms. These guys are not alike because they have different variables. So x and y are different variables. And these guys are also not alike because we don't have the same exponents on the variables p. So those are not like terms. This is a little illustration that you can refer to. Okay, So now that we've talked about what like terms are, we can now talk about combining like terms. And all that means is adding or subtracting like terms. We cannot combine terms that aren't like terms. I'm going to show you what I mean by that. So let's first look at examples of combining like terms. Say you're at the store and you are at the apples and you pick up 2 apples in your left hand and you pick up 2 apples in your right hand. And the question is, how many apples do you have? Well, you have 4 apples, right? You can combine them. You can say, oh, well, 2 apples plus 2 apples is 4 apples, right? So the answer here is 4. That's what we mean by combining like terms. We just mean literally adding them up. Then you go to the next aisle and you're looking at the pears. I know my pears aren't the prettiest pears that you've ever seen, but nevertheless, you have 3 pears in one hand. Maybe you have gigantic hands and you can hold 3 pears, and then in the other hand, you can hold 5 pears. So 3 pears and 5 pears together make 8 pears. Okay, that's what we mean by combining. We're literally just adding like things. In the apples example, the thing that's like is the apples. 2 apples plus 2 apples. In the pear example, the thing that's like is the pears. 3 pears plus 5 pears is equal to 8 pears. So what about X? It's the same thing. Go to the grocery store and you're in the X aisle. You have 3 X's in one hand. You have 5 X's in the other. How many X's do you have? Well, you have 8 X's, right? That's what we mean by like terms. We can, and really what helps is if you say what you're doing out loud. Like, if you said, what about 3x plus 5x squareds? What do I have? Well, I don't know, because what's the unit, right? The unit here is apples, the unit here is pears, unit here is x, but what's the unit when you're adding an x and an x squared? I don't know. Anyway, that's the idea. So, what about this? You go to the next aisle in this mathematical grocery store. You have 2 ABs in one hand. You have 4 ABs in the other. 2 ABs minus 4 ABs is how many ABs? Well, 2 minus 4 ABs is going to be negative 2, right? 2 minus 4. It's negative 2 ABs. So that's our answer here. That's how we can combine like terms. Okay, when can we not combine like terms? So you're at the grocery, you have 6 apples in one hand, you have 4 pears in the other. 6 apples and 4 pears makes what? I don't know. How can we say apples and pears? I mean, you could say fruit if you wanted to, but that's a whole nother can of worms that we would have to open. But the point is that we can't simplify this. We can't say 6 apples plus 4 pears is equal to 10. 10 what? 10 what, right? So we cannot combine these. So it's just, what does it equal to? It equals to 6 apples and 4 pears. That's all it equals to. We can't simplify it anymore. Same thing here. What's 2 X's? 2 X's in your hand. Take away 10 Y's. Well, what does that mean? I don't know. I don't know what that means. That's just 2x minus 10y. We can't combine anything. We can't simplify this. What about 3x squareds plus 9x's? Well, how many x squareds is that? Well, it's still 3x squareds. How many x's is that? Well, it's still 9x's, right? So the point is that we cannot combine this either because we don't have like terms. Remember, like terms, we need the same variable and the same exponents on the variable. Now let's look a little bit closer at these examples, especially the ones where we actually have the algebra. So for this one, we do have the same exponent, so condition 2 holds, but the variables aren't equal, so they're not like terms. We cannot combine them. On the other hand, with this example, our variables are equal, so condition 1 holds. However, the exponents are different. We have a 2 on the x squared and we have a 1 on the x. So we cannot combine this to make it simpler as we did in this slide right here. Okay, so what's the point of doing this? Well, the point is that it allows you to simplify expressions that can get really long and ugly. You know, when you're doing math, the whole point of math, the beauty of math, is to take something complicated and use the rules that math has for us and make it into something simple, something that's easy to deal with. That's the entire point of this, combining like terms, right? So like for this example, it says Thomas has 5 marbles in his green bag, 1 marble in his yellow bag, and 3 marbles in his yellow bag. Let M represent each marble. Well, if we let M represent each marble, he has 5 times M in the green bag, right? 5 M's, plus 1 M in the red bag, plus 3 M in the yellow bag. And so we could say, okay, well, Thomas has 5 M plus 1 M plus 3 M, or we could say this more succinctly and add all of these like terms up. What's 5 of something plus 1 of something plus 3 of something? Well, that's going to be 9 of that something. That's the whole idea of combining like terms. Because here we had 3 things to deal with. Here we only have 1 thing to deal with, right? So that's the point, to simplify your algebra. All right, so let's go ahead and do some practice. We want to simplify by combining like terms, and what I like to do is underline my like terms in the same color. So here I have 3 terms. I have 7x, negative 2x, and 4x, and these are all like terms. Condition 1. Condition 1 is that they all have the same variable. That's true, they all have an x. Condition 2 says they all have to have the same exponent on their respective variables, and that's 1. All of those have an exponent of 1 understood to be there. That means we can combine them. Think of these as apples. 7 apples minus 2 apples plus 4 apples. How many apples do we have? Well, 7 minus 2 is going to be 5 apples. Of course, I'm writing x instead of apples because that's our variable here. Plus 4x. So 7 minus 2 is 5 x's plus 4x. So 5 of something and 4 of something makes 9 of something. And that's our fully simplified answer there. That's how we can combine like terms. Let's do some more examples here. So again, I'm going to just underline my like terms in the same color. So I'm going to start with 7a. That's a term. It's all stuck together with multiplication. Do I have any other terms that are like the red term? Any other terms with the same variable a and the same exponent on a, which is 1? Well, yeah, that's going to be this guy right here, positive 5a. That's it. All right, now we move on to b. So here I have a negative 8b, and over here I have a positive 1b. Those are like terms because they have the same variable b and the same exponent on the variable 1. Okay? And that's it. What about c? I have a positive 13c, and that's it. I don't have another match to go with him, so he's just going to be yellow by himself. And then finally I have this constant, which is negative 2. All right, so how many like terms? Well, first of all, how many terms do I have? I have 1, 2, 3, 4, 5, 6 terms in total. How many terms are like terms? How many terms are like terms? Well, I have the reds, that's 1. I have the greens, that's 2. I have yellow by itself, that's 3, and I have purple, that's 4. So 4 like terms there. Well, maybe I shouldn't have phrased it like that, but I think you guys get what I'm trying to say here. Okay, so now that we've underlined our like terms, what I'm going to do is use the fact that I can rearrange addition to put my like terms next to each other. Okay, I'm not doing any combining yet. I'm just saying, well, the laws of addition says that 3 plus 5 is equal to 5 plus 3, and likewise something like 3 minus 5 is the same thing as negative 5 positive 3. Do you see what I mean? So what we call it is the commutative property of addition, means that we can rearrange the order here. So 3 plus 5 equals 5 plus 3, and 3 minus 5, remember this has a positive understood in front of it, is the same thing as negative 5 positive 3. We're literally just switching the order around. So that's what I'm going to do here. So I'm going to start with my red terms. I'm going to put those next to each other. I have 7a here, and then I have a positive 5a next to him. Okay, so those are my red terms. Then I'll do my green terms. I have a negative 8b coming up next, and next to him I'm going to put this positive 1b. For my yellow term, I have a positive 13c, and finally for my purple term, I have a negative 2. So all I did was rearrange the order so that this problem isn't so complicated to deal with, I guess. Now what I can do is I can combine my like terms, right? 7 apples plus 5 apples is how many apples? It's literally going to become 13a, 13 apples. Okay, so I just combined 7a plus 5a. Now I'm going to combine negative 8b plus 1b. Negative 8 plus 1 is negative 7b. Right? Those are like terms, so I can combine them. And then this just comes down because he doesn't have a partner, and so does the negative 2. And that's all I can do. This is our answer fully simplified. 13a minus 7b plus 13c minus 2. Okay, let's do the next one. We have 2a minus 3ba. Are these like terms? Well, they are, because multiplication commutes. Again, the order doesn't matter. So if I have 2 times 3, it's the same thing as 3 times 2. So here, since I have a times b, that's the same thing as b times a. I can switch the order around. Okay, so yes, these are like terms. I can rewrite it if I want to be 2ab minus 3ab, just so it's not as confusing. And so 2 of something minus 3 of something, 2 minus 3 is negative 1 of something. And so this is my fully simplified answer. All right, let's do this. I encourage you guys to pause the video, identify your like terms, rewrite, and then combine. All right, I'm going to start with the highest power first, which I see to be x to the 3. So I have a positive x to the 3. Keeping in mind that I'm underlining the sign that's in the front. Okay, positive x to the 3. Do I have any other x to the 3 terms? Well, yeah, I have this guy next to it. I have a negative 2x to the 3. Okay, now I'll move to my x squared terms. I only have one of them, so I'll underline that guy. And then for my x terms, I have 2. I have this negative 3x in the front, and I have this positive 8x in the back. So at this point, what I'm going to do is I'm going to rearrange using the fact that I can do that with addition. So for my x to the 3, I have x to the 3 first, followed by negative 2x to the 3. Okay, and then my x squared, I always go from biggest power to smallest power with my terms, followed by a positive x to the 2, and then my x's. I have a negative 3x followed by a positive 8x. And now I can combine. So this is understood to be 1. 1 of something minus 2 of something is minus 1 of that something. Now this guy doesn't combine without anyone. Let me see something. Let's see, yeah. This guy doesn't combine with anyone, so it's just a positive x squared comes straight down. And then these guys do combine because same variable, same exponent. Negative 3x plus 8x is going to give me a positive 5x. And that is my fully simplified answer. I have 3 terms in my fully simplified answer. Okay, let's try another one. So first comes the x to the 3 positive, then I'll do my x to the 2 terms. That's going to be this and this. Then I'll do my x terms, negative 2x and a positive x, and finally I just have a constant by itself, positive 1. So I'm going to do my x to the 3 first, followed by my x squareds. So again, guys, this 5x squared is understood to be positive. That plus sign isn't written in front of it, but it is understood to be there. So this is going to be a positive 5x squared, followed by a positive x squared, followed by a negative 2x, followed by a positive x, followed by a positive 1. Okay, now what can I combine? I can combine these guys, and I can combine these guys. Okay, and then everything else comes down. So x cubed comes down, and the positive 1 comes down because they can't be combined. But let's do the green. 5x squared plus 1x squared is 6x squared, and it's positive 6x squared. Negative 2x plus a positive 1x is a negative 1x, or just negative x. And then, of course, the plus 1 just comes down. From here, I cannot combine anymore, so this is my final simplified answer. Let's try this one. So I'm going to start by underlining my like terms in the same color. I see m, I'll make them red. Negative 5m. I see an n squared, I'll make him yellow. And I see n's, I'll make them purple. So I guess I'll do the squared first. So I have 3n squared positive, followed by, again, this is understood to be positive. There's a plus sign in front of him. Plus 9m minus 5m. And then I'll do my n's. Plus 7n plus 3 over 2n. Okay, now I can combine. So these guys combine, these guys combine. The yellow just comes straight down because he doesn't have a partner. 9m minus 5m is going to be 4m, and it's going to be a positive 4m when we do 9 minus 5. 7n plus 3 halves n. Well, do this how you want to do it. I mean, when we add fractions, we can just do 7 over 1 plus 3 over 2 and get a common denominator of 2. So 2 times 1 is 2, 3 times 1 is 3, 1 times 2 is 2, 7 times 2 is 14. Combine them. 14 and 3 make 17 over 2. So this is plus 17 over 2n. Okay, and that is our fully simplified answer. Okay, let's do a word problem. The number of miles that Roberto bikes on Monday can be represented by the expression 4a minus 3b minus 5. The number of miles that he bikes on Tuesday can be represented by 9b plus 12. What is the total number of miles that Roberto biked? So total means add. So what we're going to do is we're going to have 4a minus 3b minus 5. That's how much miles he bikes on Monday, plus how much he bikes on Tuesday, which is represented by 9b plus 12. Okay, so I have some like terms that I can combine. So I have some b's. I have a negative 3b and a positive 9b, and I have some constant numbers. I have a negative 5 and a positive 12. So the 4a doesn't have a partner, so he can just come down. And you can rewrite it if you want. Yeah, I guess we can rewrite it just to be consistent. So we have 4a minus 3b plus 9b minus 5 plus 12. Okay, so these guys, negative 3 and a positive 9 makes a positive 6b. So this becomes 4a, just comes straight down, And then these combine to a positive 6b. These, so this is a negative 5 and a positive 12, combine to make a positive 7. And that is as far as I can go. So this is our answer right here. Okay. The next thing we're going to talk about is something called the distributive property. So the distributive property allows us to multiply something on the outside of a set of parentheses to each thing on the inside. Okay, so all we do is we just do like if we have a and then parentheses with no sign in between, that means multiplication. Okay, students get confused with this. If you don't have a sign between the a and whatever the parentheses, then it's multiplication. Then you use the distributive property. So basically what we do is we take the number on the outside, multiply it by the first number, right? A times b. Then we take it and multiply it by the second number. So a times positive c. Okay, and that's all it is really. So let's do some practice. Now, this wants us to simplify this number. Now, keep in mind, I want to just show you real quick that PEMDAS says, hey, do this in parentheses to give us 2 times 4, and 2 times 4 is 8. Okay? Now, we can get the same exact answer with the distributive property. And the distributive property says we're going to do 2 times 3 and 2 times positive 1. Okay? So 2 times a positive 3 and this is going to be a 2 times a positive 1. Okay, 2 times positive 3, 2 times positive 1. Okay, so we just multiply it out through the two numbers in here. So 2 times positive 3 is going to give us 6. 2 times positive 1 is going to give us a positive 2. And 6 and 2 make 8. So that's our answer. Okay, let's do another example. We have, let me actually erase this so you guys can see it. So we have a number on the outside multiplied because there's no sign right there. And when we multiply, we can use the distributive property. So we distribute to this guy, and we distribute to this guy, right? Distribute to this guy, distribute to this guy, okay? So first thing, we're going to do 5 times negative 2. And then the second thing we're going to do is 5 times negative 3. Okay, 5 times negative 2, 5 times negative 3. So 5 times negative 2 is going to give us a negative 10. And 5 times negative 3 is going to give us a negative 15. And then negative 10 minus 15 is negative 25. And that's our answer. Okay. All right, so we can also apply the same logic when we have variables. They don't have to be numbers to use the distributive property. So again, I know I'm multiplying because there's no symbol right here. So that tells me I need to distribute. So I want to do 2 times 3. And then I want to do 2 times positive x. Okay? So we have 2 times 3. And then we have 2 times positive x. So 2 times 3 is 6. 2 times positive x is just a positive 2x. All right? 2 times x is just positive 2x. Now, if we're multiplying a number times a variable, we're not dealing with like terms here. So don't get those two confused. We can always multiply unlike terms, but we can't add or subtract them. Okay? So this is our final answer when we distribute. We have 6, 2 times 3, 2 times positive x is positive 2x. This is our answer. Okay, the next one we have negative 2 times 4. Okay, so negative 2 times 4 followed by negative 2 times negative x. Okay, oops. Okay, so negative 2 times negative 2 times 4 is a negative 8. negative 2 times a negative x. Negative times negative is positive. So this is going to be a positive 2x. Okay, and that's our fully simplified answer. Let's do another one. So we have 5 times x, 5 times positive 1. 5 times x, 5 times positive 1. 5 times x is just 5x. We can write it like that. 5 times positive 1 is a positive 5. Okay, so that's our answer there. Now, notice that I'm not putting a plus sign in front of, like, the 5x, because it's not necessary. You know, if we, it's just not necessary unless it's our second term. Like, I would have had to put the plus here. If I didn't put the plus there, it would literally just be 5x 5, and it's like, well, what do I do with the 5? I don't know. So that's why we have to put the x there. Or sorry, the plus there. Okay. All right, so here we have 2 times x squared, and then we have 2 times negative 4x. So 2 times x squared, and then 2 times negative 4, x. Okay, so 2 times x squared is simply 2x squared. There's nothing to do there. Now the 2 times negative 4x, notice that I'm not using the distributive property here because there's no plus or minus sign right there. I'm literally just doing this. Just want to make this really clear. 2 times negative 4x is literally 2 times negative 4 times x. That's what that means. There's no distributive property here. We're just multiplying 3 numbers together. So 2 times negative 4 is negative 8. Negative 8 times x is just negative 8x. So 2 times negative 4x is a negative 8x. And this is my final simplified answer. Okay. All right, so here we have 6 times 10y, and then we have 6 times negative 3xy. Okay, so 6 times 10y, and then we have 6 times negative 3xy. Fair enough. Okay, so 6 times 10y is a 60y. Then we have 6 times negative 3xy. Again, 6 times negative 3 is all we're worried about here. Everything's stuck together. So 6 times negative 3 is a negative 18, followed by xy. Again, I'm not distributing, right? I'm just multiplying, because you see this right here is very different from something like this. Right? This I would have to distribute, okay, because of those plus signs in between. But for this, I can just say, well, this is all just one thing being multiplied. 6 times negative 3 times x times y. Do you see why the distributive property doesn't apply here? Okay. So this is my answer. So if we're trying to distribute across 3 terms, if we have 3 terms in the parentheses, if we have a trinomial, we do it the same way we do it with 2 terms. We're just distributing to each of those guys in the parentheses. So let's go ahead and do that. We're distributing this guy, and this guy. And the thing that we're multiplying by is going to be this negative 2 on the outside. Notice that the negative is in front of the 2 and not right here. Otherwise, that would be a different kind of problem. And I'm going to show you what I mean by that in just a second. So, negative 2 times all of this stuff in the parentheses. So we have this times this times this, and this times this. So let's write it out. So negative 2 times 3x squared is the first one. So this is negative 2 times 3x squared. Then we have negative 2 times negative x. Negative 2 times negative x. And then, maybe I should have done this in red. And then we have negative 2 times positive 1. Okay, So negative 2 times 3x squared is negative 6x squared. Negative 2 times a negative x, negative times a negative is a positive, positive 2x. A negative 2 times a positive 1, a negative times a positive is a negative 2. And this is going to be our final answer. Now, I want to show you a different scenario. I want you to compare this original problem right here to this one. Let's say we had 2 minus 3x squared minus x plus 1. So notice the difference, how we have 2 minus instead of minus 2. Now what this says is we're taking 2 and then we're taking away negative 1 times all of this, right? The 1's not written there, but there's understood to be a 1 right here. So this is actually negative 1 times this, negative 1 times this, negative 1 times this, bringing the 2 down, okay? So let's try this version, okay? So leaving the 2 alone, okay, the 2 is just going to hang out for a second. We do the distribution. Negative 1 times 3x squared, okay? Then we have negative 1 times negative x, negative 1 times negative x, and then finally we have negative 1 times positive 1. Okay, so let me just carry everything else down. That 2 is still just hanging out, okay? With the distribution, we have negative 1, 3x squared, negative 1, negative x, and I didn't leave myself enough room, but negative 1, positive 1. Okay, so this guy, negative 1 times 3x squared, is a negative 3x squared. So I'm going to write that, and the 2 is just staying in the front. So we have 2 negative 3x squared. In the red, the negative 1 times the negative x becomes a positive x. Okay, and in the yellow, a negative 1 times a positive 1 is a negative 1. Now, we have like terms, right? This 2 in the front is a constant. This negative 1 is a constant. We can combine them. 2 minus 1 becomes a positive 1. So our final answer is negative 3x squared plus x. And again, this green, 2 and negative 1 make a positive 1. So that would be our answer if this was the situation. I hope you guys can, hopefully you can reflect on why this is different from this, okay? Just keep that in mind, okay? Because I know this is kind of confusing when you first learn it. Okay. Okay, so in this number 7, we have a number that's being multiplied on the outside to 3 terms on the inside. So we have negative w to the third, negative 2y, and positive y squared. So let's go ahead and do the distribution. So we have that, and that. Okay, so first the red, we have negative 6 times negative w to the third. Then for the green, we have negative 6 times negative 2y. And for the yellow, we have negative 6 times positive y squared. Okay? So, negative 6 times a negative. Negative times a negative is a positive 6w to the third. Okay? Negative 6 times negative 2y. Double negatives multiplied make a positive 12y. And finally, negative 6 times a positive y squared. Negative times a positive is a negative 6y squared. So this is going to be our answer right here. Okay? All right, let's do the next one. We have a negative 2x on the outside, and it's being multiplied by 2 terms, a positive x and a positive 4. So we have negative 2x times positive x, and then we have a negative 2x times a positive 4. Okay, so So again, x times x, that's just x squared, right? If we have 2 times 2, it's the same thing as 2 squared. 3 times 3 is 3 squared, so x times x is x squared, okay? So we have negative 2x squared, and then we have a negative 2x and a positive 4. Again, we're multiplying here, so we have negative 2 times positive 4 times x, right? Multiplication commutes, we can switch the order, so we get a negative 8x. And this is our fully simplified answer. We can't combine like terms because the x squared and the x have different exponents, so that is fully simplified. Okay, let's do the last one down here. We have 3 terms in the parentheses. So the first thing we're going to do is do 3y times y squared. Okay, so let me do that off to the side. 3y times y squared. Well, y squared is just y times y. So this is 3y times y times y, right? Y squared is y times y. And then a number times itself 3 times, if you remember from our exponents, is just that to the third power. So y times y times y is y to the third power. All right? So 3y times y squared gives us 3y cubed, or 3y to the third. Okay? Then we have 3y. Let me do that off to the side as well. Let's make some room here. Okay, so now we have 3y times a positive y. Well, y times y is y squared. So this is 3y squared. Okay? And it's positive. So this is positive 3y squared. We need to write the positive there because it's the second term. Right? We didn't need to write the positive here because it was the first one. And then finally we have 3y times negative 1. So 3y times negative 1, a negative times a positive is a negative. So this is a negative 3y. And that is my fully simplified answer down here. I cannot combine because I have 3 unlike terms, right? All of the exponents on the y are different numbers, so I cannot combine these guys anymore. I can't add or subtract. Okay, let's do some more examples. I encourage you to pause the video, see if you can work these examples out on your own, because I really want you guys to get this, because this is going to build on so many other concepts that we learned. So really make sure you understand what we're doing in this unit, okay? Okay, so let's go ahead and simplify these guys by using the distributive property. So I always want to distribute first when I can to get rid of parentheses. So I'll actually make a note of that. Always distribute, use the distributive property first. Okay, so here I can do that because I have a negative 1 on the outside. The 1's not written there, but it's understood to be there. And I can distribute that guy to the u on the inside and also to the positive 6. So what I have is I have a negative 1 times positive u, and then I have a negative 1 times a positive 6, and this plus 3u is still there at the end. Right? Didn't do anything there. It's not in parentheses, so I didn't have to distribute. So negative 1 times a positive u is just a negative 1u, or simply negative u. A negative 1 times a positive 6 is a negative 6, and then everything else comes down. So here I am. I have this is where I'm at so far, negative u minus 6 plus 3u. So I have like terms, and I'm going to actually rewrite it over here so you guys can see. So the like terms, I have a negative u and a positive 3u. They both have a u. The exponent on u is 1 in both cases. So I'll write those next to each other like this. And then that negative 6 is just hanging out at the back with no like terms. Negative 1 of something plus 3 of something is going to be positive 2 of something. So this becomes positive 2u, and then the negative 6 comes down, and we're done because we have 2 terms. We have 2u, and we have negative 6, and they're unlike. That means they don't have the same variable and the same exponent, so we cannot combine them. We are done here, okay? Okay, let's look at number 2. So I am going to distribute first because that's what I'm supposed to do. So, and I want to get rid of the parentheses. That's what I'm trying to get rid of first. So notice that I have a negative 3 on the outside multiplied. So the negative 3 is what I'm distributing, right? We can't forget the negative in front of him, okay? Every number has a sign associated with it that's in front of it, and we can't forget that negative 3 when we multiply it through, okay? So be careful with that. So I'm distributing the negative 3 times the positive x, and I'm also distributing the negative 3 times the negative 2y, okay? So I'm going to carry everything else down in black, plus 15. And then the colored stuff, I'm going to do the distributive property. So for the yellow, I have negative 3 times positive x is negative 3x. And then for the purple, I have negative 3 times a negative 2y. Negative 3 times a negative 2y is a positive 6y. Negative times a negative is a positive. So this is going to be a positive 6y. Okay? Now at this point, since I got rid of the parentheses, you can ask yourself, can I combine any like terms? Do I have any like terms? And I do. I have the y's. I have an 8y and I have a positive 6y. So those two, and if you want to do this, you can rewrite it if that helps you. We have 8y next to the positive 6y, and then everything else can follow after because they don't have like terms. So these two can be added. 8 and 6 makes 14. Took way too long for me to do that, but here we are. And then everything else comes down. And we are done here, you guys, because we have 3 terms. One of them has a y, one of them has an x, so they're not like terms, and the other one's just a constant, just a number 15. So we are done there. Okay, let's take a look at number 3. So you might see one like this on your homework. Notice that this plus right here has an understood 1 in front of it. So essentially we're just multiplying all of these by positive 1, okay? And then this guy has a 1 understood in front of it, so you're really just multiplying everything here by positive 1, but that's kind of just like getting rid of the parentheses. So that's what I'm going to do first. I'm just going to get rid of the first set of parentheses, and then for the second set, I'm doing positive 1 times 4x squared is a positive 4x squared. Then I'm doing positive 1 times a negative 3x, and that's going to give me a negative 3x. And then finally, I'm going to do a positive 1 times a negative 5, and that's going to give me a negative 5. So now that the parentheses are gone, I look for like terms, and I'm going to color them in the same colors. So I'll do the x squareds can be red, so I have a 6x squared and a positive 4x squared. Those are like. I only have one x term, so that doesn't have a partner, but I do have some constants that I can combine. I have a positive 7 and a negative 5. So I'm just going to rewrite this with my like terms next to each other in order from like highest degree to lowest degree. So 6x squared followed by a positive 4x squared, followed by the next highest degree is degree 1 on this x, followed by a negative 3x, then a plus 7 and a minus 5. Okay, now I can combine. So with the reds, 6 of something and 4 of something make 10 of that something. The purple can just come down, and then positive 7 and a negative 5 make a positive 2. And we are done here because we have 3 terms. The terms are 10x squared minus 3x and positive 2. And all 3 of them are unlike, because for like terms, we need the same variable, the same exponent, okay, just like we had here and just like we had here, okay? So we're done simplifying. All right, let's check this one out. First things first, these parentheses can disappear because they're pointless. We just have a 1 on the outside, and 1 times anything is just itself, so basically this just becomes 2w squared minus 3. Bye-bye parentheses. Now we have this -1 on the outside being multiplied, right? That's an understood 1 being multiplied. So we multiply him by him, her, and her. Oh wait, what happened? What was this right here? I'm thinking that was a W. Okay. So this just came down, no big deal. Got rid of the parentheses because we were just multiplying by 1. Now let's go ahead and distribute the -1 to everybody on the inside over here. So -1 first is -1 times W squared. That's and actually I'm going to write this down here just so we have more room. Okay, so -1 times W squared. Write it down if you have to. -1 times W squared is -W squared. So I'm going to carry that down here. All right, now green. -1 times -2W. -1 times -2W. That's a positive 2W. Negative times negative makes a positive. So positive 2W. And finally, we have -1 times positive 6. A negative times a positive is again a negative, so that's -6. Now I'm gonna do my like terms in the same color at this step. So I have a 2W squared is a like term with a -W squared. And then my constants are like as well. So I have a -3 and a -6. Okay, so I'll rewrite just using the fact that we can rearrange the order before combining. So we have plus 2W minus 3 minus 6. Cool, okay. So, I never give myself enough room with these problems. So with the red, 2W squared minus 1W squared is 1W squared, or simply W squared. Positive 2W doesn't have a partner, so he can just come down. -3 minus 6 is a -9. And that is our final answer. We can't simplify that anymore. We have 3 terms that are all unlike. And let's do... Why is this erasing? Let's see. Okay, I guess we'll just keep it like that. Okay, the first thing I want to do is get rid of my parentheses. That's always what you want to do first before you combine stuff. Get rid of the multiplication, okay? And so we have a negative. Don't forget about that negative before you distribute. The -3 is being distributed to the x, and it's also being distributed to the -5. Okay, so to the x, to the -5. So let's carry everything else down. 2 plus 11x plus 7x, and then let's deal with the distributing. Distributing. So for the distributing, we have -3 times positive x, and then we have -3 times -5. Okay, so I just turned this into this. Okay, just by doing the distributive property. Okay, so let me rewrite. Always, I'm super careful with these just because you can make little sign errors here and there, and it's super frustrating. Okay, -3 times x is just a -3x. A -3 times a -5. Negative times a negative is a positive 15. And now let's identify the like terms. Okay, I see some x's here. Here's a positive 11x. Here's a positive 7x. Excellent. Oh, and a -3x. And then for my constants, I have a positive 2 and a positive 15. So if I want to, I can rearrange so that my like terms are all next to each other. 11x minus 3x, positive 7x, and then a positive 2. Okay, remember it's positive because that plus isn't written in the front, but it's still positive. Positive 2, positive 15. Combine these like terms. 11 minus 3 is 8. 8 plus 7 is 15. And then 2 plus 15 is 17. Positive 17. And that's it. We're done. Okay. Let's do one more. So now it looks like we have distributive property 2 times because we have 2 sets of parentheses. The first number that we're multiplying is negative 2. The second number that we're multiplying in there is positive 3. Okay? So negative 2 times x is the first one. And then we have negative 2 times negative 4. Okay, so negative 2 times positive x, negative 2 times negative 4, and then we'll do this over here as well. So positive 3 times positive 2x, and then the last one is positive 3 times negative 1. Okay, now let's clean it up a little bit. So that becomes negative 2x. Negative 2 times a negative 4 becomes a positive 8. A positive 3 times a positive 2x is a positive 6x. And a positive 3 times a negative 1 is a negative 3. All right, cool. So we're at this point right here. Let's label our like terms. We have some x's. We have a negative 2x, and we have a positive 6x. And then for our constants, we have a positive 8, and we have a negative 3. So let's rewrite. So we have negative 2x next to a positive 6x. Then we have a positive 8 next to a negative 3. Combining the x's, negative 2 plus 6 gives us a positive 4x, and a positive 8 minus 3 is a positive 5. And that is our final simplified answer. Okay, let's see. Let's do some more practice. Again, I encourage you to pause the video and see if you can do these on your own. Okay, so first thing I'm going to get rid of the parentheses by doing distributive property. I'm distributing a positive, let me actually do this in red, positive 2 to a positive x, and a positive 2 times a negative 3. Okay, so everything else can come down. Negative 8x and the positive 7 can hang out down there. And then we'll do the distributive property. So the first distributive is, the first distributing is positive 2 times positive x, and that's a positive 2x. I'm multiplying. Positive 2 times positive x is positive 2x. Now we have positive 2 times negative 3 is a negative 6. Okay? Now I have like terms. I have a negative 8x matches with a positive 2x, and then I have a negative 6 matches with a positive 7. Okay, combining these, negative 8 plus 2 is negative 6x. Negative 6 plus 7 is a positive 1. Okay, and that is my answer there. All right, let's do the next one. So we have 3 terms in here, this one, and this one. And so for the yellow, I'll do it off to the side so you guys can see. I have negative 2x times 3x to the 4th. And to make sense of this, you can use the fact that multiplication, you can switch to order. So what this really means is negative 2 times 3. I can write the numbers next to each other. And then x times x to the 4th. Now, negative 2 times 3 is negative 6. X times x to the 4th. Think about it. X times x to the 4th is x times x 4 times, right? And how many x's do we have? 1, 2, 3, 4, 5. So that's x to the 5th, okay? So this is negative 6x to the 5th. So negative 2x times 3x to the 4th is negative 6x to the 5th. Now, let's do this in red. Negative 2x times positive 2x squared. Let's do it off to the side. Negative 2x times positive 2x squared. Again, I can rearrange the multiplication so that the numbers are next to each other when I multiply. So it's negative 2 times 2, and then the x times the x squared. So negative 2 times 2 is negative 4. X times x squared is x to the 3rd, right? Just expand these to x times x, and you'll hopefully see that. So this is negative 4x to the 3rd. And finally, in purple, oops. Finally, in purple, we have negative 2x times negative 5x. Okay, again, rearrange your numbers. Negative 2 times negative 5, x times x. Negative 2 times negative 5 is a positive 10. X times x is a positive x squared. So that's positive x squared. Again, we have to put that plus there because if not, it's not multiplication, right? It's, we distribute it out. So this is our final answer. We can't combine. All right, let's do a few more. So this one, I'm distributing negative 4 in here. So to negative 8y, but also to positive 1. So everything else can come down. The 3 and the positive 3y can come down. And so with the yellow, I have negative 4 times negative 8y. That's positive 32y. So positive 32y. Then I have negative 4 times a positive 1. That's going to give me a negative 4. Okay. Combine like terms. I have a positive 32y, and I have a positive 3y. And then for my constants, I have a negative 4 and a positive 3. So I'll just rewrite just to get the point across here. So the positive 3, I'm adding that plus because now it's not in the front anymore. Okay. Combining like terms, 32 and 3 makes 35y. 3 minus 4 makes a negative 1. And that is simplified. Alright, let's do this crazy thing right here. Now look at this pointless parenthesis that we can just get rid of, make it look a little bit cleaner. Right, because there's a 1 in the front, but who cares about the 1? It just, when you multiply the 1 through, it gives you the same thing that's in the parentheses, so let's just forget about the parentheses. But over here, I got to be careful. I got to multiply the positive 5z squared into this parenthesis. I have to use the distributive property here. So for the yellow, I have 5z squared times 6z. Again, use the property of multiplication that says that it commutes. We can switch the order. So I'll put the numbers next to each other when I multiply, and then I'll put the z's next to each other when I multiply. 5 times 6 is 30. Z squared times z, well, z squared is z times z. Z times z times z is z to the third. So this becomes a positive 30 z to the third. Okay, now the purple, I have 5z squared on the outside times positive 3. So again, 5 times a positive 3 times a z squared is just a 15z squared. Okay, like terms, I have z squareds. I have 5z squared, and I have a positive 15z squared. And that's it. And actually, I'm going to write the 20z to the third first. Followed by the positive 5z squared, followed by the positive 15z squared, followed by the positive 2z. Okay, so these can combine because they're like. 15 and 5 make 20z squared. So I have 20z to the third, positive 20z squared plus 2z. And that is my final answer. I have no like terms here, so that is it. Okay. Next thing I want to talk about is something called FOIL. This is just a special case of the distributive property. And the acronym FOIL stands for first, outer, inner, last. So it's just a way for you to remember how to distribute. Okay, and I'm going to show you how to do it. So when we have to use FOIL, sometimes it's hard to recognize when you have to do it. And the way that you can recognize it is if you have two set of parentheses with no sign in the middle. When there's no sign in the middle, you FOIL because it's telling you to basically multiply these two things. If there was a plus or a minus sign, you would not FOIL. okay? But if there's no sign, that means multiply. We're going to FOIL. So let me show you how to do it. It's just the distributive property, and it's just distributing to everything you can distribute to, if that makes any sense. So let's do first, okay? So FOIL says do first, and that means the first term in your parentheses. So first you're doing A times C. So A times C is our first. Okay. Outer is your outer term, so like on the outside of the parentheses. We have A is this one on the outside, and positive D is this one on the outside. So you're going to do positive A times D. So that's your outer terms. It's O. Your inner terms are going to be the innermost things. So like positive, maybe I should have done this. A times positive B is outer. Your inner terms, here we have inside the parenthesis a positive B times the other number that's inside the parenthesis is positive C. So this is positive BC. This is our inner. And our last is going to be the last things in the parenthesis. So B is last in the parenthesis here. D is last in the parenthesis here. So this is a positive BD. That's last. Oh, I guess I got my colors mixed up. Dang it. Maybe we should just say this is orange. I did yellow for inner, so maybe this is yellow. And then last was purple. Okay. So that's how you do it. So you just use the distributive property, but you're distributing everything you possibly can. Okay? So that's FOIL. AC plus AD plus BC. So let me show you how to do it. So 1 plus 2 squared, well, we know what that is by PEMDAS. Well, 1 plus 2 is 3, 3 squared is 9, 3 times 3. But we can use FOIL to do this, actually. Because 1 plus 2 squared just means 1 plus 2 times itself. Any number squared just means multiply it by itself twice. So 1 plus 2 squared is 1 plus 2 times 1 plus 2. Now we can apply FOIL. So first, 1 times 1. Outer, 1 times positive 2. Inner, positive 2 times positive 1. And last, positive 2 times positive 2. Okay? Simplifying this out, we get 1 times positive 2 is positive 2. Again, 2 times 1 is just a positive 2. And then 2 times 2, positive 4. Add them all up. 4 plus 2 plus 2 plus 1, you get 9. So that's how we can use FOIL with just a problem like that. Okay, we can do it with x's and stuff too. It's the same kind of idea. So here I'm just going to say x plus 3 squared. Don't ever do this. That's completely wrong. Really wrong. Don't do it. What this means is multiply x plus 3 by itself. That's what x plus 3 squared means. Don't forget that. Okay, so we're going to apply FOIL first. X times x. Outer, x times positive 3. Inner, positive 3 times x. Last, positive 3 times positive 3. Okay, x times x is x squared. X times positive 3 is a positive 3x. 3 times, or positive 3 times x is just positive 3x, and positive 3 times positive 3 is positive 9. I have like terms in black. So This becomes x squared positive 6x, right? Like terms, positive 9, and that is my final answer. That is my answer here, fully simplified. Okay, let's do another one. Okay, so this is, all right, so first, outer, inner, last. Again, why am I using FOIL? Look, no sign. No sign. Up here, I used FOIL because there was no sign when I used the definition of squaring something. So again, no sign, that means multiplication, means use FOIL. So first, 2x times x is 2x squared. Outer, 2x times positive 4 is a positive 8x. Inner, negative 1 times positive x is a negative 1x. Last, negative 1 times positive 4 is a negative 4. Like terms in black. Positive 8 minus 1, that's a positive 7x, so those like terms become positive 7x, and we're done. There is nothing more that we can simplify here. Alright, again, we can use FOIL, look, no sign. So, first, x times x, x squared. Outer, x times negative 6, negative 6x. Inner, negative 8 times positive x, negative 8x. Last, negative 8 times negative 6, positive 48. Like terms in black. So in black, negative 6 minus 8 is negative 14x plus 48. And we're done. We cannot simplify this anymore. We have 3 terms, all unlike. Okay, let's do one more, and then we'll be done. Okay, again, we are using FOIL because there's no sign right there. Okay, first, negative x times 3x is negative 3x squared. Outer, negative x times negative 5 is a positive 5x. Inner, positive 2 times positive 3x is a positive 6x. Last, positive 2 times a negative 5 is a negative 10. Like terms in black. Combine them. Okay, so 5 and 6 makes positive 11 minus 10. Alright, and that is our answer. Alright guys, I hope you enjoyed this lesson. Really reflect on this lesson. If you're not understanding something, really think about it and try to go back through your notes and figure it out, or, obviously you can ask me. This is really important for building up on what we're going to do next and what we're going to continue to do. So it's really important that you understand this part. Alright, thanks for watching. See you guys next time.